guys, how are you? I'm back. I got my Mickey ears, actually my mini ears. I got my Choose Happy shirt on today. I may or may not be wearing pajama pants. I'll let you decide. And I'm here to tell you a little bit more about complex numbers in polar form. So let's do it. We are going to talk about today, gotta find my pen, multiplying and, my pen not doing really well, hold on. I'm back. Multiplying and dividing complex numbers in polar form. And then we also have to talk about something called DeMoivre's Theorem, which is basically raising a complex number in polar form, raising that to a power. So we're going to start with multiplying and dividing. There's formulas for both of them. And then there's a formula for DeMoivre's theorem. So it's just a matter of having the formula and knowing how to use it and making sure you're putting the numbers in the right places and just working it out. So there's not a lot to it. I'm just going to go over the formulas with you. I hope everybody is doing well. Not going too stir crazy and keeping up with school. Yeah, so like I said, I'm hanging out. I got my ears on and that's that. All right, so let's see here. I am going to switch over to my camera here. Let's make this bigger. And let's move me out of the way. Okay, so hopefully this is focused in where you guys can see it. Okay, so we're gonna do multiplying. Let me try to write where you guys can see it. Multiplying and dividing complex numbers in polar form. Multiplying and dividing complex numbers in polar form. So it's been a minute since my last video. In the last video, you guys were actually sort of converting the complex numbers into polar form and back. So the first thing that we have to sort of remember to be able to do this is what the heck does a complex number look like when it's in polar form? So in the last video, we talked about how, well, a lot of times we will use Z to represent a complex number, either in kind of what we think of as the regular complex number, which is just A plus BI, or now we have the polar form of a complex number. So we said in the last video that we have this R value, which is sort of like how we were always kind of thinking about the R value. It's like the distance that you move out from the pole or from the origin to get to where your complex number is. And then we also have cosine theta plus I sine theta. So that's what our complex number looks like when it's in polar form. So what we're going to talk about today is, well, what if we have two of those and we wanted to multiply them together, or we wanted to divide the two of them? So we're going to call this one Z1, and then I'm going to go through this one and call this R1 and theta 1 here and here. And then we're going to suppose that we have another one that we might want to call Z2, and it's going to look the same, except we're just going to call this R2. This is going to be cosine theta 2 plus I sine theta 2. And we want to multiply those together. Move my situation around a little bit here to get some room. Okay. So like I said, there's a formula for multiplying and dividing these together. So I'm going to show you both of the formulas, and kind of talk through it, and then we'll do a couple of examples, okay? So the multiplication formula, if we wanted to multiply Z1 and Z2 together, the first thing we have to do is multiply the two R values together. R1 times R2. And then we're still going to have this bit in parentheses, but what we have to do to sort of combine them together, we're going to still have the cosine here, but instead of just a single angle, we're going to add the two of these together. So it's going to be the cosine. I'm going to have a little, actually, I'm going to put this part in brackets so I don't have so many parentheses floating around. So I'm going to do brackets, and then here I'm going to do parentheses, and we're going to add the two angles together. And then we're going to do the same thing for the sine. We're going to have plus I sine theta 1 plus theta 2, and then my bracket. So you can see that when we multiply them together, the answer is still going to have the same form as the two original things we started with. We're still going to have a number here, just like we had a number out front for both of these. And then we're still going to have a cosine thing here that we're going to have to figure out, just like we had up here. And then I sine of another thing that we're going to have to figure out. So the form kind of looks the same. It's just a matter of knowing how do we combine the two R values that we had up here, and what do we do with our angles to kind of combine them. Okay, so if we want to multiply the two numbers together, we're adding the angle measurements. Okay, it's sort of similar. It kind of makes me think of, if you guys remember anything about like logarithms, and when you talk about logs and you learn all those rules about expanding logs and condensing logs, kind of reminds me of that. Because if we had things that were added together, like two logs that were added together, if we wanted to condense it back down, it became multiplication. And so it's kind of in the same vein as that. All right, so there's the formula for multiplying. That's what we're going to do to multiply. And then for division, if I wanted to do Z1 divided by Z2, you can probably guess, again, if you kind of remember a little bit about those log rules, again, it's kind of similar. You might be able to sort of make some predictions about what we're going to do here. So we're going to start off similar to what we did with the multiplication, but instead of multiplying the two R values together, we're going to divide the two R values together. And then we've got our bracket, and we're going to have our cosine. But instead of adding the two angles together, now when we're dividing, we're going to subtract the angles. So it's going to be theta 1 minus theta 2 to get a brand new angle. And we're going to have to sort of evaluate that probably in our examples in just a second. And then we have our I and our sine, and again, theta 1 minus theta 2, our bracket. So one kind of common question I get a lot when we do this is, well, which one is Z1 and which one's Z2? So whichever one is the numerator, that's what we're going to call Z1. So whichever one you have in the numerator, that R value is going to go on the top, and the other R value is going to go in the bottom here. And then you're going to subtract the angles in that order. So whatever angle was in your Z1, that is going to be, you're going to subtract the other one from that. Does that make sense? So you'll see when we do the examples here in just a second. And sometimes when you do this subtraction, you could end up with a negative value. So we could be taking the cosine of a negative angle or the sine of a negative angle, but that's okay. We know how to do that. There's another little caveat to the division. We have this formula where Z2 and R2 can't be a certain value. So you can, again, probably predict what Z2 can't be. since we're dividing, or we're, you know, thinking about it in maybe numerator and denominator. Same thing with R2. R2 is in the denominator of this fraction. So you can probably predict that neither one of these can be 0. If that happens, then everything kind of blows up in our face and we can't really do anything because we get some things that are undefined. All right, so let's look at some examples. So let's say that my first number is 3 cosine 20 plus I sine 20. And then my second number is 5 cosine 100 and I sine 100. And we're going to use these for both multiplying and dividing. Oh, another thing that I forgot to say a second ago is if anybody's wondering, you know, why the heck is this the formula for multiplying and why the heck is this the formula for division, I do have some proofs of those. They're pretty short proofs. If anybody wants to see those, I'm happy to take a picture and email them to you. I usually don't really like show where they come from unless somebody is just curious and they want to know. I'm sure you could Google it as well. But if you're interested, I do have a little like handout that I printed out that kind of shows where those formulas come from. Okay, so back down to this guy. So we're going to multiply these two numbers together. I'm going to do Z1 times Z2. Okay, so if I look back up at my formula, according to my formula, the first thing I have to do is multiply the two R values together. So the R value here is 3. Our value on this one is 5. So I'm going to have 3 times 5. And then I'm going to have my bracket. And then if I look back up at my formula, all the way back up here, it tells me that I'm going to be taking the cosine of the two angles added together. So this is going to be the cosine of 20 plus 100. And then I've got my I, and then sine of 20 plus 100 over here. Obviously, this is some stuff that you could probably do in your head, right? You won't necessarily have to write out 3 times 5 and 20 plus 100. You could probably skip this first step, but you know, it's the notes, so I'm kind of writing all this stuff out. So this is going to be 15. This is going to be cosine of 120 and sine of 120. So then we have to think about how to evaluate that, because we want to leave our answer sort of in kind of the regular complex form. So we have to think about the cosine of 120 and the sine of 120. So 120 degrees, that's like 2 pi over 3. So this is going to be 15. And then I'm going to go back to parentheses. Cosine of 2 pi over 3 is -1/2. And then the sine of 2 pi over 3 is √3/2. Make sure I get my I in there. And then we can distribute our 15. So I'm just going to leave this -15/2 and then 15 √3/2i. And we can just leave it like that. Okay, so we're going to use those same two numbers and we're going to do the division for those. So turn the page. Okay, so I'm going to recopy my numbers up here. So this is 3 cosine 20. This is I sine 20. Then we had 5 cosine 100. I sine 100. So we're going to divide. We're going to do Z1 divided by Z2. I could just as easily go the other way around. I could do Z2 divided by Z1 if I wanted. It would just change the answer a little bit. But if we look back at our formula, the first thing we have to do is divide our two R values. So we're going to have 3 divided by 5. And then when we get to our cosine and sine, since this is division, we're going to have to subtract our angle measurements that we had. So since I'm doing Z1 divided by Z2, I'm going to be doing 20 minus 100. So this is going to be cosine 20 minus 100. And then here, same thing, 20 minus 100. So then we'll have our 3/5. This is going to be cosine of negative 80. This is going to be sine of negative 80. Oops. Sorry if you can hear background noise. There's some people unpacking groceries in my house. So then this might be a thing where we'd have to grab our calculator, right? Because 80 degrees or even negative 80 degrees, I don't really know that off the top of my head. So some of these, you're going to get some angles that you may not just know from the unit circle. So you may have to grab your calculator to help you with some of these. And for those, you're probably going to end up with decimal values. You want to make sure you're obviously in the right mode. This is degrees that we're in. So we want to make sure that our calculator is in degree mode. So we're going to do cosine. Let me double check my mode. Okay, I'm in degree mode. So I'm going to do cosine of negative 80. That's going to give me 0.174. 3/5. So this is 0.174. And then if I do sine of negative 80, that's going to give me negative 0.985 if I round, and then I'll have my I. And then I can distribute my 3/5 to that. And we should end up with something along these lines. 591 I when we divide them. Okay, so that's an example of our multiplication and our division. I'm going to do one more so we can see another example of that. All right. So this time, our angles are going to be in radians. So cosine 5 pi over 3. And then 4 cosine pi over 6. Okay, so I'm going to go through the multiplication and the division. If you want, you can pause the video and then kind of do both of them and then watch and see how you did. All right, so for multiplying, I'm going to have to multiply the two R values. So So that's going to give me an 8. Then I'm going to have to add my two angles together. So 5 pi over 3 plus pi over 6. And then over here, same thing, 5 pi over 3 plus pi over 6. So if I get a common denominator between these two, this is going to be 10 pi over 6 plus another pi over 6 is 11 pi over 6. So then I have to think about where 11 pi over 6 is. It's in the fourth quadrant, almost a full loop around, back to 2 pi, but not quite. So the cosine at that position is root 3 over 2. And the sine at that position is negative 1/2. So then I can go through with my 8. This is going to make 4 root 3 minus 4i. So there's our multiplication. And I'm going to flip over and do my division. Z1 divided by Z2. Actually, let me do it on the other sheet because you can kind of see through that. There we go. Z1 over Z2. All right, so Z1 over Z2, that means I'm going to have a 2 divided by 4. I'm going to have cosine. I'm going to do 5 pi over 3 minus pi over 6. And the same thing over here. The sine minus pi over 6. So let's see, we said if we got a common denominator, here, I'll go ahead and make this a 1/2. We said if we got a common denominator, this would be 10 pi over 6 minus 1 pi over 6 is 9 pi over 6. So that's the same as 3 pi over 2 if we reduce. So then we have to go through and figure that out. So bring my 1/2. So cosine of 3 pi over 2, that's going to be 0. Sine of 3 pi over 2 is minus 1 or minus I. So then if we bring through our 1/2, we're just going to have negative 1/2 I as our final answer. All right. So that's the multiplying and the dividing if you have complex numbers that are in polar form. Now, the last thing I'm going to talk about is this thing called DeMoivre's theorem. So this is obviously named after a French person, probably a dude, right? Because that's how it worked back in the day. So this is for raising a complex number to a power. Raising a complex number to a power. So we have our complex number that we're calling Z, and we want to raise it to some power, n. So again, we have a formula for this. So we're going to take the R value that's out in front. We're going to raise that to whatever the power is. Then we're going to have our cosine. And instead of having cosine of theta, we're going to take that power, that n value, whatever it is, and we're going to stick it in front of that angle. So it's not just theta anymore, it's going to be n theta. And then we're going to do the same thing with our sine. And then we just have to go through and kind of evaluate it. The little caveat you can add on to the end of this one, we can say where n is greater than or equal to 1. All right, so I've got 3 examples to show you. All right, so our first one, our number is already kind of in this polar form, and then we just kind of have to apply the formula to it. So we have 2 cosine 20 degrees I sine. So that's our number, that's our complex number, it's in polar form. And we want to take that and we want to raise it to the 3rd power. So I'm basically just going to do what this formula says up here. It says I have to take my R value and raise it to the power. So I'll take our 2, raise that to the 3rd. And then I have to take that power and multiply my angles by it. Notice we're multiplying the angle by that power. We're not raising the angle to the power. That would be huge, right? We're not saying 20 to the 3rd power. We're just saying cosine of 3 times 20. So that's a little bit different. Put my brackets back in here. And then I sine of 3 times 20. So it changes our angle measure, but not as much as if we were actually having to raise it to that power. That'd be a little crazy. So then we're going to end up with 8. This is going to be cosine of 60. I sine of 60. So 60 degrees, that's like pi over 3, right? So cosine at pi over 3 is 1/2. The sine at pi over 3 is root 3 over 2. And again, I can bring in my 8 to both of these. So this is going to be 4 plus 4 root 3 I. And so that's our complex number that we had up here raised to the 3rd power. If we worked on it until we got it all the way back into that regular form, okay? Now, some of the ones though that you're gonna see, this won't already be in polar form. You might actually start out with something like this that we need to raise to a power. So let me show you what that would look like. So let's say that we've got 1 plus I to the 5th power. So our formula only tells us what to do when it's in polar form. So that means that the first thing we need to do is to put it in polar form. So this is what you guys were working on in the last video, right? We're trying to turn this into the thing that's got the R and the cosine theta and the sine theta. So we have to remember from the last video that R is found with this formula and our angle is found with that formula. So if I real quick try to get my R and my theta, so this is going to be 1 squared plus another 1 squared. So this is going to be the square root of 2. And then over here, inverse tangent of 1 over 1. So here's where we have to be a little bit careful because we want this angle to be in the same quadrant as our original number. So this is one of those times when you have to kind of stop and think about your answer. So this number that we started with, 1 plus I, this is in the first quadrant. So that means when I get my angle down here, that also needs to be in the first quadrant. So we need to find a place in the first quadrant. We need to find an angle in the first quadrant that has a tangent of 1. So that's going to happen at pi over 4. So that means that if I put this into polar form, it's going to look like this. And we want to raise that to the 5th power because that's what it told us to do up here. So I'm going to raise this to the 5th power. So then that means I'm going to have root 2 to the 5th power. Then I'm going to have cosine of 5 times pi over 4. I'm going to do the same thing with my sine. 5 times pi over 4. If you work out root 2 to the 5th, it's like root 2 times root 2 times root 2, 5 times. If you work all of that out, that's going to end up being 4 root 2. And then this is going to be cosine 5 pi over 4 and sine of 5 pi over 4. And then we have to go through and figure out what that's going to be. So let's say 5 pi over 4 is down in the 3rd quadrant. So the cosine there is negative root 2 over 2. And then the sine is also going to be negative root 2 over 2. And then we're going to have to distribute this. So the 2's in our denominator, we're going to be able to simplify with the 4. This root 2 times that root 2 is just going to make 2. So if we do all of our simplifying, let's say this is going to make a 2. This is going to also make a 2. So that I think is going to be negative 4 when all is said and done. And then same thing with this one, minus 4i. So that's our final answer for that one. Obviously that one was a little bit longer because we had to do this part up here first. We had to get it in this form and then do our formula for the power. Okay, I'm going to do one more like this one where you have to do all this first bit. Okay, so this one, we've got 4 plus 4 root 3i. We want to raise that to the 6th power. But again, this one's not in polar form yet. So that's the first thing that we have to do. We have to get our r and we have to get our theta. So I'm going to have 4 squared. I'm going to have 4 root 3 squared. And then over here, I'm going to have inverse tangent of 4 root 3 over 4. Okay, so I had a question from somebody the other day about squaring something that looks like that. This has got like a number and then also a root. So let's talk about that for a second. Obviously 4 squared is going to be 16. But then here, this square is going to go to both of these. So this 4 squared is going to be 16. This root 3 squared is just going to end up being a 3, and those get multiplied together. So this is going to end up being 48 plus another 16 is 64, which is going to give us 8 as our R value. Over here, my 4's are going to cancel. So I have to think about where am I going to find a place on the unit circle that has a tangent of root 3. And again, I have to make sure that I'm thinking about the proper quadrant. So I look back up here at my original number that I was given. This is in the first quadrant because both of these are positive. So I need to think about a place in the first quadrant where tangent is going to be √3. These are a little bit harder than the pi over 4 places, but I believe that's going to happen at pi over 3. So now I know that my polar form looks like this. And according to my original problem, I have to raise it to the 6th power. So that means I'm going to have 8 to the 6th. Then I'm going to have to multiply 6 pi over 3. Same thing with this, 6 times pi over 3. 8 to the 6th power, pretty big number. That is 262,144. Let's see, this is going to be 6 times pi over 3, 6 pi over 3. That's just 2 pi, right? This is going to be cosine 2 pi. This is going to be sine of 2 pi. So let's think about this. Bring down this crazy thing. Okay, so cosine at 2 pi is just 1. Yes. Sine at 2 pi is 0. So this whole part we can just say, oh, that's going to go away. And then this times my 1 is just that. So we end up, our answer just being a real number, which is kind of a weird thing to think about, that you can take a complex number that's got both parts, it's got a real part and an imaginary part. And when you raise it to a certain power, do all the work, and you just end up with a real number. The imaginary part just ends up going away altogether. All right, so now you know how to multiply two complex numbers that are in polar form. You know how to divide two complex numbers that are in polar form, and now you know how to do DeMoivre's theorem, which is to raise that same kind of number to a power. Let me see if I can make this a little bit smaller. Okay, so here, I'm back. Still got my ears on. All right, so you guys have a homework assignment that should pop up Tuesday. I'll go in and double check the dates, but it should pop up Tuesday, the 31st at like 8 in the morning, that will cover this stuff that we just talked about, the multiplying, the dividing, the DeMoivre's theorem. That's in the Alex thing that I told you about, that I made the video. If you haven't watched that video, please do. It tells you how to get in there, how to access Alex, and how to get to the homework assignment. It tells you how to avoid all this other stuff that you don't need to see. So let me see if I can share this one. I'll show you where that video is. So if you go into the all teams and you go under files, so there's this Alex homework tutorial right here. It's pretty short little video, but you can go in, you can watch that, and you guys will do that homework assignment all in Alex. You have multiple times to try it. If you get something wrong, it's going to let you do it over again if you want. If you don't really care and you're happy, you know, you get like an 80 on the homework assignment and you're happy with that, then stick with an 80. But if you want to keep trying until you get them all right, you can do that. Let's see, what else? There also should probably be a Google form that will be posted around for the 31st as well. So when you watch the video, when you watch this video, go in, get the Google form, fill it out, just so I know that you guys are keeping up with everything. I can also kind of see that through the fact that you guys are doing your stuff in Alex. There's also a previous assignment from the previous video that's also in Alex that I think has the same due date as the new one that goes with this video. So make sure that you've got both of those completed, because those are going to be your homework grades thus far. I'll still do the live session Tuesday afternoon for you guys if anybody has questions, or you just want to check in and say hi. I got an email that they're going to turn on everybody's cameras, all the student cameras for Teams, so I can see your beautiful faces. So come visit me and say hi during the live session, even if it's just to pop in and, like I said, let me see your lovely faces. Okay, so that's that. Bye, guys.